Alright, so I think this is recording. Let's take a look at these building functions from functions. We've got two functions. They've just called them f and g, and we're using f and g to create new functions, and then also we'll want to find the domain of these new functions. So here for a and b, it's just asking you to combine like terms. So for a, we'll add f of x and g of x together. We can look up here and see that we'll have x cubed plus x cubed, that we'll have 2x cubes. We've got negative 4x squared plus 5x squared for plus 1x squared. We've got 3x minus 6x for minus 3x, and negative 9, minus 9 minus 1 minus 10. And for the next one, we're subtracting all of g. So when we have x cubed minus x cubed, they cancel. When we have negative 4x squared minus 5x squared, that's minus 9x squared. We've got 3x minus a negative 6. Well, subtracting the negative 6x is like adding 6x. So we'll have 9x. And then we've got negative 9 minus a negative 1, which is the same as negative 9 plus 1. And that's minus 8 if I haven't made a silly error. And you may actually want to write it out if you are prone to silly errors, so that you can visually see how to change the sign of all of the terms in the second function. But those are my answers for A and B unless you tell me otherwise. Let's go ahead and take a look at number 2 and put it on the same video. So here in A, B, C, and D, it's the same idea. Here it's asking us to add this new function. They're giving it the name f plus g of x, but also through that name it's just telling me to add these two functions together. So when I do that, I only have a 1x cubed, 8x squared, 3x and another 3x for a total of 6x, and minus 9 and minus 16 for minus 25. So if I haven't made any silly arithmetic errors, and you guys are probably better at it than I am on combining like terms and not making silly errors. F minus g, well, when we subtract g, all of these signs are going to change, so I've got a negative x cubed here, then plus 8x squared. 3x minus 3x, the x's cancel. Negative 9 minus a negative 16, same thing as 16 minus 9, which is 7. So again, if I haven't made a silly error, my answer in C should be the same as my answer in A, because addition is commutative. It doesn't matter the order at which we add these functions together. For subtraction, the order is important, but if we change the order, then we just have to change the sign. In other words, like with arithmetic, 5 minus 3 and 3 minus 5 are equal and opposite. This one's 2, this one's negative 2. So if I have the 2 and I want to get the 3 minus 5, I just change the sign. They're equal and opposite. So it won't be equal to this guy, it'll be the opposite of this. So if my answer in B is correct, then my answer in D should also be correct. Now for the domain, one nice thing about building these functions, if we add or subtract or multiply these functions together, it doesn't even matter the order at which we subtract them, the domains will be the same. So the domain for A, the domain for B, the domain for C, the domain for G are all the same domain. So we can always intersect the two domains. we want to find the domain of f and intersect it with the domain of g. Well, the domain of f and the domain of g are extremely easy to find because we don't have any variables in a denominator in either one of them, and neither one of them has any square roots. So the domain is all real numbers. And when we're finding the domain of this f plus g or f minus g or any of these, we intersect these two ideas. So if we have the domain of f, which is all real numbers, and we have the domain of g, which is all real numbers, then we can find the domain of f plus g or f minus g or g minus f by intersecting these two sets. Well, to be in the intersection, you have to be in both sets. But all of the real numbers are in this set, and all of the real numbers are in this set. So all of the real numbers are in both sets. So that's our answer, is that in E, the domain for all four of these, for part A, part B, part C, and part D, the domain is all real numbers. Hope that helps.